The Silicon Frontier, inside SpaceX's $119 billion Terafab megaproject. When a rocket company decides to manufacture chips, Elon Musk has once again erased the word impossible. What began as a $20 billion rumor in March has rapidly escalated into one of the most ambitious industrial undertakings in history. On May 7, 2026, SpaceX officially filed for property tax abatements in Grimes County, Texas, revealing that the initial investment for its Terafab facility has jumped to $55 billion, with a total long-term project value of $119 billion. To understand the gravity of $119 billion, one must look at the national landscape. The entire U.S. CHIPS and Science Act authorized $52.7 billion in total subsidies to bolster the nation's entire semiconductor industry. SpaceX's single private project effectively doubles the scale of the federal government's total investment. The Terafab is set to rival, and potentially exceed, the massive investments currently being made by TSMC and Intel in Arizona and Ohio. According to filings, the facility will be located near the Gibbons Creek Reservoir, repurposing a former coal-fired power plant site. This brownfield location provides existing high-voltage grid infrastructure and a reliable water source, two critical requirements for a high-intensity chip fab. Unlike traditional chip companies that focus on a single part of the supply chain, the Terafab is designed as a next-generation vertically integrated semiconductor and advanced computing manufacturing facility. Reports from Mexico Business News and the Next Web highlight a unique division of labor: the hub, Grimes County, large-scale mass production of logic chips and memory. The R&D wing, Austin/Bastrop. Tesla will continue to operate smaller pilot lines at its Austin campus for rapid prototyping. The partnership. While Musk is driving the project, industrial rumors suggest a strategic collaboration with Intel, utilizing their foundry services expertise to help bridge the technical gap for SpaceX's first-generation silicon. The demand for high-end silicon across Musk's companies has reached a breaking point. SpaceX is no longer just a transportation company. It is a hardware and AI conglomerate. Starlink's 10-tome low plus satellites. Each satellite and millions of ground terminals require custom, radiation-hardened chips. Tesla's AI ambitions, from FSD, full self-driving computers, to the Optimus humanoid robot, the need for proprietary, low-latency AI chips is paramount. xAI's compute hunger. Musk's AI startup requires massive GPU clusters. The Terafab's goal is to produce 1 terawatt of annual compute capacity, an astronomical figure considering the current total U.S. capacity is roughly half that. Industry experts remain cautiously pessimistic due to the sheer difficulty of the task. While building a Starship is a feat of engineering, fabricating chips at 3 nanometers or 2 nanometer scales requires mastering atomic-level physics. A primary concern is the procurement of EUV, extreme ultraviolet, lithography machines. These machines, produced exclusively by the Dutch firm ASML, cost up to $400 million each and have years-long waiting lists. Whether SpaceX can secure enough equipment to meet its 2028 to 2029 production goal remains the project's biggest question mark. The choice of Grimes County is a massive win for the local Texas economy. The June 3rd public hearing at the Justice and Business Center in Anderson will likely finalize the tax abatement agreements. By choosing a former coal plant, SpaceX is not only lowering land costs, but also participating in industrial recycling, turning an old energy site into the heart of the new energy and AI economy. March 2026. The project is first teased with a $20 billion estimate. May 2026, official filings reveal the $55 billion Phase 1 commitment. June 2026, local government votes on tax incentives. 2028 to 2029, targeted first light for the fab, beginning with internal use chips for Starlink and Tesla. If successful, The Terafab will represent the ultimate realization of Musk's first principles philosophy. By refusing to rely on external suppliers, SpaceX is attempting to become a self-contained technological superpower. As noted by All About Circuits, this move doesn't just challenge TSMC and Samsung, it changes the definition of what a space company or an auto company can be. We are entering an era where the lines between software, space exploration, and atomic-scale manufacturing are officially gone. The Terafab project begins with a vision that pushes the boundaries of possibility, leveraging lessons from history and technological breakthroughs. From its brownfield location to its radical vertical integration, every decision is guided by a commitment to innovation and efficiency. The timeline from rumor to reality shows rapid escalation, reflecting the urgency and ambition behind the project. Historical places like Grimes County are transformed by new technologies, blending tradition with the future. Books and inventions guide the strategy, inspiring a new generation of semiconductor manufacturing. The demand from Starlink, Tesla, and XAI shows how interconnected Musk's ecosystem is, relying on advanced chips for diverse applications. Technical hurdles at the atomic level remind us that innovation is both challenging and rewarding. Economic impact ripples from Grimes County to the global tech landscape, turning local sites into international hubs. Timelines and milestones mark the journey, showcasing the project's evolution and anticipated breakthroughs. Text quotes and illustrations reinforce the key ideas, making the story clear and memorable. As we look ahead to 2029 and beyond, the Terafab sets a new map for global tech, redefining what is possible.